So according to the books, any computer system that is reusable needs to store data in a structured way so that it can be reused in the future. One of the most powerful tools in computer science is the ability to search large amount of data and obtain results very quickly. So we will study data structures that enable effective and efficient computer-based storage and searching that may take place. So data types allow programming languages to provide different classifications for items of data so that they can be used for different purposes. Integers are discrete whole numbers used for counting and indexing, whereas real numbers can be used to provide accurate measurements. All right, so that really depends on what sort of data that you are saving. So you would have to actually connect the data that you want to save and retrieve later with the type that suits best for it. So you need to be able to understand and make appropriate use of data types. When writing pseudocodes or programs, you would have a good idea of data types as we have studied it earlier. You would have already studied it in O-levels as well. The other day we also discussed different data types. So in short, data types that we have are Boolean, character, we have date, we have time, integer, real, and string. Now, in pseudocode, for Boolean, we have got Boolean. For character, we have char. This is how we represent it in pseudocode. Then we have got date. If it is time, then we will be using like this. Time, integer, real is real, and string is string. Sometimes we may use for text as well. So Visual Basic.NET, that's Boolean, character is char, date time is date, or time, integer is like integer, real is single, and string is string. All right. So this Boolean is logical values, that is true and false. Character is a single alphanumeric or any special character that you see over the keyboard. Exact representation is ASCII or Unicode. Date and time is basically value in numbers that represent the date. Integer is a whole number, positive or negative. Real is basically a positive or negative number with a decimal point, and a string is a sequence of alphanumeric characters, which is essentially made up of characters. Then we discussed a little about declaration. So in pseudocode and some other programming languages like Visual Basic, before data can be used, the type needs to be decided. This is done by declaring the data type for each item to be used. Each data item is identified by a unique name called identifier. So in pseudocode, the declaration would be in AS level. Since the question paper will be pseudocode heavy, it is absolutely necessary to choose a language that is close to the pseudocode. So at AS level, I teach Visual Basic .NET because that complements pseudocode a lot. And then in A2, we will be studying Python. So declaration in pseudocode will be something along lines declare, identify, as data type. All right. So example might be declare my name as string, declare date of birth as date. All right. So that is how we declare. Declaration is necessary from exam's point of view because whenever there is a variable or an array or constant, it needs to be declared before it is used. Even in languages like Python, where declaration is just done by assigning the first value to it, it is absolutely necessary to somehow mention, maybe through comments, that the variable is declared and what is the type of it. Okay, so sometimes what happens is that we need to declare a data type which is composite in nature. Composite in nature, it's like a record. It's like a record in database, but it's not database. So in that case, we use records. We will be having great great use of these records in filing. All right, so we will be studying filing later on. So we will be making use of these records things over there. So these are composite data types formed by the inclusion of several related items that may be different data types. For example, let's say there is a record of a student ID, a student name, student class, student address, student fee, student grade. Maybe there might be other things as well. So what do? We create student ID, student name, student class, student address, student fee, and student grade. So ID will be, let's say, integer, name would be string, class would be, let's say, string as well, address would be string as well, fee will be, let's say, real. Grade would be character. So we have to declare all these separate identifier or variables for every data that we want to save for this record. But these are several related items which are different data types, but they are related. All right. So this is a type of composite user-defined data type. What we basically do, we can create our own data type which is composite in nature and which can hold all these 6 fields. So I will put type over here, type. This is the syntax. Type, and then I've got end type. And I'll name this type. Let's say I name it type T for, let's say this is my type, so I'll start it with the word, sorry, with the character type, student record. All right. So that is how we actually declare a composite data type. Now, when I will like to have a record of this data type, which is composite made by me, the user, and I want to put some data in it, I would have to declare a variable of this type whose name is student record. Type is student record. So I'll be like, declare James record as type student record. You see, so this type is basically this, which holds all of it. Now, when I'll put data in James record, I'll be like, James record dot student ID is equal to 1003. James record dot student name is equal to James Kotha. Let's say James record dot student class is A to C. James record dot student address is equal to Karachi, Pakistan. James record dot student fee is equal to 2403.0. James record dot student grade is equal to C. You see? So you whenever there is a number, we just put it that way. If it is a string, we put it in double quotation. If it is a number, maybe of type real, we just put it this way. And if it is a character, we have to put it in single quote. That is how we basically create records data type. These are user defined, means we decided and we put it this way. So first we create a type and then we make variables of those types. These variables which are created are of record or composite data types. All right, and then they belong to this type, and this type we have to first create. And then we can use this in here, and with the dot, we can use any of the field that we have created inside that particular user defined data type. So this is composite data type, which is made up of other types which are related. So records are composite data types formed by inclusion of several related items that may be different data types. Okay, as we have done over here. Over here. This allows a programmer to refer to these items using same identifier, enabling a structured approach of using related items like we have done over here. A record will contain a fixed number of items, as we have got like 6 items over here. All right, so for example, a record of a student can include student ID, name, class, address, fee, and grade. All right, so a record data type is one example of the composite user-defined data type. We will study this composite user-defined data types in A2 thoroughly. But over here, just we have to take care of this one thing because we are going to use it in filing. A composite data type references other existing data types, means these are existing data types. Intrinsic data type, these are called, which are there and given by the language itself. A composite data type references other existing data types when it is defined. A composite data type must be defined before it can be used, as we have defined it over here. Any data type not provided by the language, like this particular itself, record data type must be defined before it is used. So this is basically pseudocode approach. All right, this is pseudocode. In Visual Basic, we will be using the word structure. All right, structure and structure. Structure, and let's call it student record. And then we be like him, student ID as integer, him, student name as string dim student class as string dim student address as string dim student fee as single. Remember, this fee is basically a real number. And then we have got dim student grade as character and structure. Now, when we declare a variable, we be like dim my record as student record. All right, so the two match. Now, if I have to put some data in it, then I'll be like my record dot student ID is equal to 352. My record dot student name is equal to Zafar. So this dot any of these. All right. So you may create several different records like dim your record as student record. And now you'll be like your record dot student ID is equal to 300. Your record dot student name is equal to Ahmad, and so on and so forth. So you get the idea. This is a different variable. This is a different variable, and they both are basically composite data type variables. They exist differently in the RAM. They hold different data, and they will be called differently whenever they are used. So we may have several students records with several different names. So this is basically composite data type alongside basic intrinsic data types that we have in the language. All right. So whenever we will be studying anything, we will also be studying with reference to the Visual Basic. So that is how it works. Now, let's go ahead and discuss about other things. Hold on for a minute. So हमने discuss किया था कि we need to understand types and their declaration that we have finished. And there then comes identified table. What does it mean, identified table? Identified table requires you to choose names of the variables, their types, and their description. All right, so let me pull up one of the file that basically requires you to understand identifier tables, and then we do this file size calculation along this identifier table. Hold on. Before we go any further, let us discuss about the sizes of the types, basic sizes. Okay. Boolean is 1 byte, character is 1 byte, date time is 8 bytes, integer is 4 bytes, and string is as many requires. All right, so about the string, we will see that what sort of data that we are going to store, we will decide it on our own. But other Boolean character, date time, integer, single, they all are basically predefined. So mind those. Let's solve few questions so that you have an idea that what sort of question we may have. Details, let's solve them reverse order. They just do. So this is June 18 question. Programming languages support different data types. Give an appropriate data type for each of the following variables. My greetings would be a string. My initials would be string. Age in years would be integer. Weight would be real. Married or not is basically Boolean. All right. You get good marks for it choosing different data types. Okay. This is identified. Accelerator. Accelerator pedal positions value 0 to 100 in steps of 1, meaning 0 is this, 100 is that. What is the data type? We can see that it is a whole number between 0 and 100. So data type would be integer. Engine temperature in centigrade. This is from -50 to +150 stored in one decimal place. One decimal place. So this would be real. Normal temperature. Normal engine temperature in degree C. Whole number. So this is integer. Road speed of car in kilometers per hour. Values is 0 to 200 steps of 1. So this is integer. Value used to signal engine must be stopped. True or false? So this would be Boolean. So this is called identifier table that has the identifier, the type, and its description. And now sometimes you will have to put your description by yourself. So remember, description has two parts if it is a good description: explanation and example. See, these two parts are there: explanation, example, explanation, example, explanation, example. All right, explanation, example. And if it is possible, give possible values extra. Example should include possible values so that your examiner would have clear idea that what sort of data you are going to save and why have you chosen this particular data type. All right. So horses are entered for a horse race. A horse may have to carry a penalty weight in addition to the rider. This weight is added to the saddle. The penalty weight, if any, depends on the number of wins the horse has achieved in previous races. The penalty weight is calculated as follows: number of previous wins 0, penalty is 0, 1 to 2, 4, over 2, greater than 2, then 8 kgs. Program is written from the following structured English design. There is a separate lecture for structured English, you will see in it. Input name of horse, so horse name, horse name, number of previous wins, calculate penalty weight, store penalty weight, name, output name of horse, and penalty weight. So we have to have these three variables. Horse name, previous wins. Horse name would be string. Previous wins would be integer. Penalty weight would be real. Okay. So now horse name, data type would be string. Description would be the name of horse. Since we don't have a lot of space, so that's it. Name of horse, participate. Second one is previous wins. That is integer. So number of wins in previous games. And then we have what? Penalty weight. This would be real. Is it real? Since it is not described, let's make it real. You may make it integer as well, since they have the example that they have given is integer. Penalty weight applied as per previous wins. All right, so this is basically the identifier table. Identifier, data type, and description. Now, the company now wants a program to key in date entered by the user, search the text for the file for this date. If found, output one of the following message. If not found, then output this message. Get the identifier table to show the variables you need for this program. Now, a company creates two new websites, Site X and Site Y, for selling bicycles. Various programs are to be written to process the sales data. This program will use data about daily sales made from Site X using variable sales X and Site Y using variable sales Y. This is sales date. All right, so we have got what? Sales date, sales X, sales Y, but this is an array. Okay, so this is an array. This is index. This is an array. The discount dates text file is successfully created. Add the identifier table to show the variables you need for this new program. So discount dates, then we have what? Sales date, sales X, sales Y. So we have got sales date, sales X, sales Y. So this is date, this is integer, this is integer. date on which sales were made, items sold from site X, items sold from site Y. There might be more variables that you can include, but apparently we see just three, and there are 3 marks allocated for it, so it means that this is enough. So such type of questions will appear. So you would have to actually read the scenario, and then you will have to fill this particular identifier table. So I hope that you have an idea of identifier tables. You have an idea of how to read this requirement and see that what sort of data we need to basically acquire. And according to that type of data that we need to acquire, we will be creating few of the identifiers types. If you can understand all the types, intrinsic data types, the types which are provided by the language, you can relate these data types to the required scenario. And the description is actually hidden inside the questions themselves. You would have to complete this identifier table. Okay, so filling in identifier table will require you to know how to make the names of identifier, what are the data types, that's about it. Okay, so now only the file size calculation remains. We have discussed types, we have discussed declarations, we have discussed identifier table, and now we will be discussing file size calculations in next lecture.